Okay. Now we look at the types of adsorption process. Either it is molecule or atom. Okay. First, we look at the definition of isotherm. Isotherm is the amount of gas absorbed on a solid at different pressures but at one temperature. A model system was proposed. The isotherm obtained from the model is compared with the experimental data shown on the curve. So yang ni, if you learn about the adsorption isotherm, you will know. So then, if the curve predicted by the model agrees with the experimental data, the model may reasonably describe what is occurring physically in the real system. So this is just a definition. But the most important that you need to know is the type of adsorption, how the adsorption occurs. Okay, first, the former is called molecular or non-dissociated adsorption. So, non-dissociated adsorption is the molecule adsorption. Maksudnya, the reactant adsorb to the active site of catalyst as a molecule. Okay, for example here, CO, molecule CO attached to the active site of catalyst as reversible reaction and produce CO.S. So this is the equation how the adsorption occur. Okay. Then another type is the latter is called dissociative adsorption. Dissociative adsorption is the reactant will adsorb as a molecule. Okay, again, for example of CO, carbon monoxide, so it will adsorb as an atom. Therefore, the adsorption reaction require two active sites for the atom to attach. So CO plus 2S. Kenapa 2S? Because one of the S will attach with carbon and another S will attach with oxygen. And via reversible reaction and produce C.S plus O.S. So ini maksudnya the reaction deadsorb as a atom or dissociative adsorption. Okay, then it is depend on the surface. The equation can be considered as an elementary reaction in order to determine the rate law. Okay, so for adsorption step, when you have how the adsorption occur, either molecular adsorption or atom desorption, and from that you need to write the net rate of adsorption. So because the reaction is reversible, so you need to know how to write the rate law equation ataupun rate law of adsorption step based on reversible reaction. So for reversible reaction, rate of attachment to the surface minus rate of detachment from the surface. So the definition of rate of attachment, rate of detachment, you already learned it in reaction engineering 1. Similar with the net rate of adsorption, it's similar with net rate of reversible reaction. And then when you write the net rate of adsorption, then we use the assumption to obtain Lamour isotherm. Okay. So the Lamour isotherm is based on the surface of the catalyst and also the adsorption system. Okay, if you don't remember how to write the net rate of reversible reaction, later we will look at the example. Alright, first example for non-dissociated adsorption. Okay. Consider the adsorption of carbon monoxide Okay, because the reaction is non-dissociated, so it will absorb as a molecule. So the equation of absorption is CO plus S. Reversible reaction will produce CO dot S, molecule carbon monoxide that attach to the active site S. Okay, so the definition, this is just the definition of how to write the overall rate law. Okay, first, rate of attachment ni similar with rate of forward reaction. Okay, Ka is the rate constant for forward reaction. Actually, A ni referring to species CO, ataupun we also can say Ka is the rate constant for the absorption process. Ka is rate constant absorption, okay, for forward reaction. Okay, PCO, okay, because the reaction is CO is gas, so we write it as a partial pressure. Okay, for the reaction, if the reaction is in gas phase, we write it in terms of partial pressure, not the concentration. If the reaction is liquid phase, we write it in terms of concentration. So kalau liquid carbon monoxide, KaCO, concentration of carbon monoxide in liquid phase. But now the reaction is in gas phase. So we write it in terms of partial pressure. That's why Ka, rate constant of absorption, multiply with partial pressure of CO, multiply with CV. So concentration of active site always CV. So yang ni jangan ubah. Okay. Then we look at the rate for backward reaction. Okay, rate of detachment. Rate of detachment similar with rate of backward reaction. Okay, so in this case, detachment ni detachment of carbon monoxide from the active surface. Rate of attachment, attachment of carbon monoxide onto the active surface. Okay, then rate of detachment equal to K minus A, rate for backward, rate constant of backward reaction of absorption step, multiply with CO dot S. Okay, before this I said that the reaction is in gas phase. Okay, but when the molecule attached to the active site, dia dah jadi concentration. So we write it in terms of concentration. CO dot S. Cuma yang previous equation rate of attachment tu Ka PCO because sebelum attach dia in terms of gas. Dia still in gas state. Okay, before attached to the active site of catalyst. So it is in gas phase. So that's why Ka, Pa, Cv. Okay, then overall rate law ataupun net rate of absorption is RAD. RAD is net rate of absorption. AD ni bermaksud absorption. Equal to, then it's always positive. The sign is always positive because dia bukan pseudo homogeneous rate lagi. Yang ni rate of absorption. So always positive. Okay. So equal to Ka PCO CV minus K minus A CCO dot S. So similar step on how you write the net rate law equation for reversible reaction. Okay, then at equilibrium, we have this definition, equilibrium constant. Okay, therefore, we simplify the equation as RAD equal to Ka, then dalam kurungan PCO CV minus CCO dot S per Ka. Right? So this is the net rate of non-dissociated adsorption. Okay, then after that, okay, first step, you need to write the net rate law equation. So in previous slide is the net rate law equation for non-dissociated adsorption. When you have the rate law, after that, you need to write the side balance equation. Okay. So the side balance bermaksud concentration of active site, total concentration of active site. CT equal to CV plus CCO dot S. Then at equilibrium, CCO dot S equal to KACV PCO. How we get this equation? So I will show it later in another video. Example, how to write the Lamour isotherm equation or adsorption isotherm equation. Okay, solve it, relate it with the overall net rate law. Okay, then solve the concentration of CO dot S in terms of constant and partial pressure. Thus, we will get this equation. And this equation called adsorption isotherm equation or Lamour isotherm.